Hi everyone, let's start section 5.3 on solving trig equations. We did a bit of this back in 4.7. Let's do more of this more systematically. First of all, we're going to look at basic equations in sine, cosine, cosecant, or secant. Notice my two exceptions, tangent and cotangent, and think about how they're different, by the way. How are tangent and cotangent different from these other guys? And we're going to consider linear forms in these trig functions, linear forms. Meaning, if you do a substitution, you basically get a linear equation. For example, here, if we try to solve this equation, 5 cosine of x minus root 2 equals 3 cosine of x. Well, you might want to apply the substitution. You don't have to, but you can apply the substitution u equals cosine of x and start by solving this linear equation, 5u minus root 2 equals 3u. Solve this for u. In fact, let's go ahead and do that. 5u minus root 2 equals 3u. Let's start by adding 2 to both sides. So we add 2 to both sides. Don't say move, say add. Add root 2 to both sides. Subtract 3u from both sides. 5u minus 3u is 2u. To isolate u, divide both sides by 2. U equals root 2 over 2. And then sub back, u was cosine of x. Cosine of x equals root 2 over 2. Now, you did not have to do a substitution. You could have just left this in cosine of x. Many students do. So again, add root 2 to both sides, divide by 2. In either case, whether you use a substitution or not, we get cosine of x equals root 2 over 2. And we basically solved a linear form for u or cosine of x. So we started off with some basic algebra. And now we look at cosine of x equals root 2 over 2, and we might think, oh, piece of cake. Well, take a step back and think. It's easy to write down something wrong here. This looks deceptively easy. We want to solve this equation, and the assumption is that we solve it on R. We want all real solutions for this equation, and therefore all real solutions for this equivalent equation over here. We want all real solutions. That's the assumption, unless you're told otherwise. Find all real solutions. That is assumed unless otherwise stated. So first of all, if you consider x as an angle, that might be a bit confusing. But if you consider x as an angle and you consider the unit circle, the way that some instructors do it, they would put cosine of x on the horizontal axis and sine of x on the vertical axis. Okay, because it can be a bit confusing. It is true that cosine of x is like an angle here. Cosine of x is like the x coordinate on the unit circle. It's the horizontal coordinate. Okay, so we want to know in what two quadrants is cosine of x positive? First of all, actually, you should agree that root 2 over 2 is a legitimate cosine value. It's between -1 and +1. So this is a legitimate cosine value. And in fact, it's a well-known cosine value. It's a famous one. Root 2 over 2 is a famous one. But once again, in what two quadrants is cosine positive? Remember, cosine of x is the horizontal coordinate. I don't quite want to say x coordinate. It's the horizontal coordinate on the unit circle. X is technically the angle here. Well, cosine is positive in quadrants 1, I'll put that in blue, and then blue, right? And quadrant, what else? Quadrant 4. Quadrant 4, the horizontal coordinate. Okay, we used to think of it as the x coordinate. Here, x is technically the angle, though. But in quadrants 1 and 4, cosine is positive. All right. Well, it helps to find the reference angle for the solutions. And in fact, the reference angle turns out to be a solution itself. What's the inverse cosine of root 2 over 2? What is the famous acute angle, quadrant 1 angle, whose cosine value is root 2 over 2? It is pi over 4. So let's start with that, with pi over 4. This northeast point, we know that pi over 4 is in fact the reference angle, actually, for all the solutions. In what other quadrant is cosine positive? Quadrant 4. So we're also interested in this point over here. And what angles could we associate with this point? Well, there is 7 pi over 4, but since we want all real solutions, do you know what an easier representative for this point would be? By representative, I mean any coterminal angle that would correspond to this point over here. You can pick any one. Which of those representatives for this point would you pick? What's even easier than 7 pi over 4? How about negative pi over 4? We want all real solutions anyway. It turns out this makes things convenient for us. So what is our solution set for this equation? Cosine of x equals root 2 over 2. I want any representative for this point over here and all its coterminal twins, basically all the representative angles for this point. And I want all the representatives for this point. So I pick one representative, and then I take all of its coterminal angles. So very simply, by the way, remember these points here correspond to a horizontal coordinate of root 2 over 2. Remember the horizontal coordinate is cosine of x, the cosine value of the angle. Easy way to write the solution over here. The set of all x in the reals, I like to put that nowadays, the set of all x in the reals, sneaking that in there, such that x is of the form plus or minus pi over 4 plus 2 pi n, where n is integer. Here's the shorthand for that, where n is in the set Z. And we want both the plus and minus signs in there. And that would be an appropriate solution set. It has infinitely many solutions corresponding to the infinitely many angles that correspond to both this point and to this point, including pi over 4 and its coterminal twins, and negative pi over 4 and its coterminal twins, including 7 pi over 4. Now, if you really like positive angles, or if you're going to do a multiple angle type problem, like we're going to see later on, you might prefer the 7 pi over 4. That's okay. You could just as well write the solution set as follows. I will accept any solution set that's correct, within reason. The set of all x in the reals such that x is of the form pi over 4 plus 2 pi n, where n is integer. Again, that can be written like this. That takes care of all the representatives for this northeastern point over here in quadrant 1. Or of the form x equals 7 pi over 4 plus 2 pi n, where n is integer. That gives us all the representatives for this southeastern quadrant 4 point over here. I'll accept either the solution set in red or in blue. In fact, you can take any representative, any coterminal angle for pi over 4 over here, and any representative for this point in the southeast, or any coterminal angle for 7 pi over 4 over here. For that matter, you can switch these two guys. As long as your solution set is correct and reasonable, I'll accept it. although books try to aim for the most compact and efficient form possible. Bear in mind, I needed the plus or minus in front of the pi over 4 here, unless I was going to write out different angles like 7 pi over 4 over here. So I needed the plus or minus here if I wasn't doing something like that. But I don't need a plus or minus here because remember, n could be a negative integer. N could be -1, -2, or so forth. So if you were to put a plus or minus sign here, that would not be wrong, but it would be redundant or superfluous. N can be negative. So we leave it as plus 2 pi n. That's how we get all possible coterminal angles, by putting plus 2 pi n where n is integer. We go around an integer number of revolutions, either counterclockwise or clockwise. So that was our first solve a trig equation problem in this section. Remember, your answer to a solve an equation problem is a solution set. Now, actually, there is a way of visualizing this. And we'll discuss that briefly next time.